Alright, so in this problem we're using implicit differentiation to find the first derivative and second derivative of x to the 2/3 plus y to the 2/3 equals 1. So we're going to go ahead and start by finding the first derivative. We'll use the power rule here. We've got 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3. We've got to make sure we apply the chain rule here. And then we take the derivative of the right-hand side, and the derivative of 1 is 0. And now we want to solve for dy dx, so I'm going to go ahead and move the 2/3 x to the negative 1/3 over to the right-hand side. And divide both sides. Forgot my dy dx when I wrote that. And divide both sides by 2/3 y to the negative 1/3 to get dy dx. So I've got negative 2/3 x to the negative 1/3 over 2/3 y to the negative 1/3. And since those exponents are negative, I can move those variable expressions to the other part of the fraction and make the exponents positive. And I can also cancel out the 2/3 from both numerator and denominator. And if I do all of that, it leaves me with the opposite of y to the 1/3 over x to the 1/3. So that's my first derivative. Now we're going to take the second derivative. So we'll go ahead and take the derivative of our first derivative. We're going to apply the quotient rule. So we've got low, x to the 1/3, times the derivative of high, which is going to be negative 1/3 y to the negative 2/3 dy dx, minus high times the derivative of low, and then we're going to square our denominator as well. And we're off and running. And so we want to simplify this. So we've got negative 1/3 x to the 1/3 y to the negative 2/3 times dy dx, which is negative y to the 1/3 over x to the 1/3, plus 1/3 y to the 1/3 x to the negative 2/3. All that over x to the 2/3. Now I'm going to do some simplification here. First I'm going to focus on this first term and combining the x's and y's. What I can do there is, since I have an x to the 1/3 in both numerator and denominator of this term, those will cancel each other out. And then I can combine the y's by just adding the exponents. So I'm going to go up to the top here. Combine those by adding the exponents. And that makes that term negative 1/3 y to the negative 1/3, because negative 2/3 plus 1/3 is just negative 1/3, and plus 1/3 y to the 1/3 x to the negative 2/3, all over x to the 2/3. Now from here, I want to get rid of the negative exponents that exist in this fraction. So in order to do that, I'm going to multiply the numerator by y to the 1/3 and x to the 2/3. And in order to preserve the value of the fraction, I'm going to do the same to the denominator. And that gives me, now the y to the positive 1/3 and the y to the negative 1/3, add those together, it becomes y to the 0. remind you I'm focusing on my first term here. And so this first term becomes negative 1/3 y to the 0 x to the 2/3 when I multiply that expression through. And then I'm going to focus now on my second term. I've got a 1/3. And then y to the 1/3 times y to the 1/3 becomes y to the 2/3. And x to the negative 2/3 times x to the 2/3 becomes x to the 0, or just 1. And when I multiply the denominator by that, it becomes x to the 4/3 y to the 1/3. Now, a couple other things I want to do here. First off, since I have 1/3 as the coefficient for both terms in the numerator, I can factor that 1/3 out in front. And when I have 1/3 in the numerator, it's just like having 3 in the denominator. So I can go ahead and move 3 down into the denominator and get rid of that 1/3. In the initial numerator. Now there's one more thing I'm going to do, because I'm observant. We see here we've got x to the 2/3 plus y to the 2/3, which was exactly the left-hand side of our original equation. So I can replace that with a 1. And so our second derivative ends up being 1 over 3x to the 4/3 y to the 1/3. I hope that helps for any of you who might have had questions on example number 2 from our worksheet. All right. See y'all next time.